So like I said, today what we're starting with is graphs, and we're going to sort of just start with the foundations of talking about patterns. Because at the end of the day, patterns are relationships. So a pattern describes a relationship between two variables or two values. And once we have a pattern, or once we have or are able to say what the relationship is, we can start to draw graphs that represent this relationship. So what this then allows us to do is it allows us to make predictions or sort of future projections about a relationship. Now, what I mean by that is if we think about a real life context, we can think of something like in business, if we want to talk about what future profits a business could make. So let's say we're selling some sort of product, I don't know, we're selling a smartphone, and the business wants to predict whether or not or how much profit they're going to make. If they can figure out what the relationship is between how much they sell the smartphone for and how many smartphones they sell, they can figure out what the profit relationship is. And so understanding patterns, understanding relationships is super important, just in like general applications in the world. If you think about like stock markets, these are all based on trends and patterns. If we think about, now I can't think of another single example. If we think about just like data handling or statistics, all of this relies on relationships between variables. And so being able to identify relationships is really important. So that's sort of what we're going to have a look at today, because like I say, this is going to very much build the foundation of what we're going to eventually start talking about. Okay, if you have not done number patterns, please don't worry. Like I say, the videos are on Watobe's website. You can go have a look there. We're going to start off very basic, and we're going to add in complexity as we go along. So if we have a look at this first number pattern that I've given you here, you've got the numbers 3, 5, 7, 9, and 11. So my first question is for you to describe the pattern. And then my second question is to write down the next 3 terms. So when I say terms, the terms are each of these values in the sequence. So this would be the first term, second term, third term, etc., etc. Just in case you didn't get the first bit. So my first question, let's deal with the first part of this, is what is this pattern? What is happening from me to get from 3 to 5 and then from 5 to 7? And to essentially get or continue this pattern, right? Matthew, do you want to tell us?
Hello, ma'am.
Hi.
And what we are doing is we are all adding, like we are adding 2 to every number.
Excellent, well done. So what we can see here is that to get from 3 to 5, I added 2. To get from 5 to 7, I added 2. And so every single time to get from one value to the next, I am adding the number 2. Now, the ladies also said that was sort of like a relationship is that all of these numbers are odd numbers. And so it makes sense that if I've got an odd number and I'm adding 2, I'm going to continue this pattern of odd numbers. Okay, so as Matthew said, if we want to now describe this pattern, we don't really need to write a whole long essay. We would just say that we're adding 2. So from one term to the next, we will add 2. Good, Matthew, well done. Right, Asanda, do you want to give us the next 3 terms?
Yes, miss.
Okay, tell me.
It's 13 and 15.
13, 15, and the third one?
And 17.
Good, well done. So guys, if we just keep adding 2, 11 plus 2 is 13, 13 plus 2 is 15, etc., etc. Now, if we remember number patterns, we know that once we know what the pattern is, I suppose, once we know that we're adding 2 each time, we can eventually come up with a rule or with a formula to describe any term in the sequence. And we are going to chat about this again, just sort of something to remember or to bear in mind. And we're going to look at different ways of illustrating or showing these patterns or these relationships. One of them is through an equation. Another way is through graphs. So on that note, if I'm adding the same number every single time, you can put it in the chat or you can raise your hand. What do you think the graph of this pattern would look like? If I'm adding exactly the same thing every single time, what do you think the graph is that I would draw? What would it look like? Now, you might not know the answer to this, and that's absolutely fine. You can take a guess if you want. We are going to eventually chat about it. I'm really just making you think a little bit. So if you don't have an answer, that's cool. Right, Palesa Modise, do you want to tell us what you think it would look like?
Ma'am, I think it's gonna be a telegraph.
A what graph, sorry?
A table. Right.
Okay, so remember when we talk about graphs, we're talking about like either a line or like a curve or something like that.
Oh, ma'am, it's gonna be a curved.
Okay, why do you think it's going to be curved if we're doing the same thing every single time?
Because ma'am, it's gonna be. Oh no, ma'am, it's straight because the number's gonna be increasing.
Exactly, well done. Okay, so everyone on the chat has said linear, or as Palesa's described, we could say it's a straight line. Because I'm adding exactly the same thing each time, my slope or my gradient stays the same. I'm increasing by the same amount each time. And so what I'd end up getting is a straight line. Now, don't stress if you didn't get that. Like I say, we're eventually going to start drawing graphs and talking about these things, but it's important to start thinking about these things. All right, Asanda, do you have a question?
No, miss.
Okay, no problem. Okay, guys, so we've described one pattern and we've described one relationship. Let's have a look at a second one. So I'll give you a second to think about the second pattern of 1, 5, 9. Oh, golly, sorry, everyone. 13, 17. I want you to think about what you're doing to get from one term to the next, and then again, the next 3 terms. Right, Kelly, do you want to tell us what you are doing to get from one term to the next?
Ma'am, I said you add 4 to get the next number.
Excellent. So each time we add 4. So 1 plus 4 is 5, 5 plus 4 is 9. And so I keep going, adding exactly the same number each time. Good. So if we want to describe this pattern, we would say exactly that. We are adding 4 every time. Whoops. Okay. Again, guys, remember this is maths. We don't need a whole long paragraph essay. Just add 4 is good enough to describe the pattern. Alrighty. So, Emmanuel, do you want to tell us what the next 3 terms would be?
Evening, ma'am.
Hi.
Yes, ma'am. So 17 plus 4 will be 21.
Good.
Then 25
Good.
and 29.
Excellent. So guys, we just keep adding those 4s and we get our next 3 terms. Excellent. Well done. Right. I do still see some hands. So if you still have a question, obviously leave your hand up. Otherwise, you can put your hand down. There is more examples, so there will be more opportunity to answer.
My people are on fire today. They like flowing on these things. Hey, my peeps, y'all are doing really good. Good job, my people.
Okay, let's have a look at this one. A little bit different, not quite as straightforward as the first 2. So again, I'll give you a second to think about what pattern you see going on here, what you sort of think you do to get from one term to the next. It's the same question, describe the pattern and give the next 3 terms. So take a second and think. And then if and when you're ready, you can put your hand up. So my pattern is 4, 5, 8, 13, 20. Okay, Letu, do you want to tell us what you think is happening in this pattern here?
Hello, ma'am.
Hi.
Don't you, whatever you added from the last time, don't you add 2 on top of that?
Okay, explain what you mean.
So for the first one, you add 1, ma'am.
Okay.
And for the second one, it's 5, 6, 7, 8. You're adding 3. So you
Okay,
added
so
2 on top of the 1.
okay, so sort of something like that situation.
Yes, ma'am.
Awesome, well done. So that's actually a really good point that you've made here, and I'm gonna come back to that in a second. So a lot of you on the group were saying you're adding on odd numbers, which I would agree. We add a 1, then a 3, then we add 5, then we add 7. So what we're doing here in terms of the pattern is we are adding consecutive odd numbers. Now, guys, consecutive means it follows in like a pattern. It follows in an order. Consecutive, that's not how you spell consecutive, sorry. So if you think about your odd numbers, it's 1, 3, 5, 7, 9, 11, etc., etc. Now, numbers, sure. Now, what has been pointed out, and this is quite a cool thing to have already seen, and this is something that we'll actually expand more on in grade 10 and actually look at why this is the case, is if we then look at the odd numbers, each time that odd number increases by 2. And so rather than like in the first 2 examples, where initially we added the same number each time. So here we initially added all 2s and all 4s. If we then look at the pattern of what we're adding in this third example, it is there that I'm adding a constant value. Now, don't stress too much about the specifics of this. It's just a cool thing to see. And like I say, we're going to expand more on this in like grade 10, grade 11. But this specific type of pattern is actually one of the patterns that we will investigate more in depth. So well done on spotting that. But essentially at the end of the day, we're adding consecutive odd numbers. So Manincle, do you want to give us the next 3 terms of the sequence?
Sorry, ma'am.
Oh.
I was late, ma'am, because it was like load shedding at Pietermaritzburg.
Okay, no problem. You haven't missed too much. All we've sort of done is looked at 2 number patterns, and we are carrying on with that now. We are doing graphs. This is just like the foundation of it, but you can catch the recording and catch it all up. So don't stress.
Okay, thank you, ma'am. Have a good day.
Alrighty. So we want the next 3 terms. I hope I say your name correctly. If I don't, you can correct me. Paperi. Whoops.
Yes, ma'am.
Did I say it correctly?
Yes, ma'am.
Okay. What are my next 3 terms?
29.
Good.
40.
Good.
53.
Excellent. So this was plus
53.
9. Oh, sorry. This was plus 9.
Yeah,
No,
I'm nailing this. Yeah.
it was plus 9 from 20. So we added 9, then we added 11, then we added 13 exactly to get us to 53. Well done.
Thank you, ma'am.
Nice, guys. You're on it tonight. Okay, so this pattern was a little bit different just because it wasn't the same thing that I was adding each time. But as Emmanuel's put in the chat, this is what we actually call a quadratic pattern. Now, this is not like something specific you need to know in grade 8. Some of you might have done it, but it is not actually something you need to know the specifics of. It's cool to see. It's cool to start seeing the relationship because this is what a function is eventually going to be. But we get a whole bunch of different types of patterns that we can work with. Alrighty, Palesa, do you have a question, Mondisa?
No, ma'am. Ma'am, I actually noticed something. So we were skipping one number each time.
When you say
from sorry.
No.
So ma'am, right from 1, we skipped 2, and then we went to 3, and we skipped 4, and then we went to 5, and then and so forth.
Okay, good.
So
now that's, yeah.
So ma'am, Is it like gonna be like this in every other question?
Not necessarily. So this is, like I said, this is a very specific type of pattern. We call them quadratic patterns. You don't need to stress about that right now. But this is one of the specific types of patterns we look at, where we might skip the same number of values each time. So in this case, like you said, we skipped one number, which means that if I wanted to go from 1 to 3, I'd actually be adding 2 so that I could skip over 4. And this is why we highlighted the fact that if I look at these numbers that I add each time and then look at their pattern, I'm adding 2 each time so that I can skip the even numbers.
Oh, okay. Thank you, ma'am.
Well done. Well done. Okay, Tato, do you have a question?
Yes, ma'am. I wanted to ask if we can go back to A and B. I forgot to take a screenshot.
No problem. Okay, guys, so let's just go back to A and B so that you can take a screenshot. I'm going to put them together, and then I'll go back down to C for you to take a screenshot. And then we're going to have a look at one more. Mutlago, it doesn't necessarily only happen with odd numbers. I could add 2, 4, 6, 8 each time. So it's not necessarily only odd numbers. That was just the example I used. What is important is the concept, I suppose, like Palesa was talking about in terms of, oh, it's gotten very dark all of a sudden, is this idea that we skip the same amount of numbers each time. If you want, as soon as everyone's taken a screenshot, I'll give you another example and you'll see what I mean, but it can happen in various different ways. So there's A and B, here's C, just to sort of continue this conversation, because I mean, patterns are cool and it's always cool to start seeing these things. I'm going to give you another one and you can see what I mean by my whole long spiel. You can write this down if you want, guys. This is just an extra example. So let's go, I don't know. I just have to get my maths brain working, guys. I do apologize. Okay, so let's say I gave you that pattern. If we have a look at this, I can see that each time I add like a multiple of 3. So this is plus 3, this is plus 6, this is plus 9. So I'm still skipping numbers. I'm skipping, adding 4, 5, and I'm skipping adding 7, 8. And this makes sense. I'm now skipping over 2 numbers. So if I now go and have a look at a pattern, oh golly, sorry everyone. If I now go and have a look at sort of like the pattern between these ones, this is plus 3. This is plus 3. And what we see is that it is a constant sort of difference. And that was very similar to what we saw over there. And so this is actually one of the defining characteristics of a quadratic pattern, is what we call the second difference. And guys, I'm really getting into specifics here. You don't need to know this. But if there is the same difference between what you're adding each time, this is what we call a quadratic. Now, you don't need to know the specifics, like I say, but this is just in response to Mutlago's question on the chat. It doesn't only have to be adding odd numbers. It can be adding anything, as long as when I add and I figure out what the pattern is between what I'm adding, it's like the same value each time that I'm increasing or decreasing by, then it's essentially the same type of pattern. But good question. It can come up in a range of different ways. So well done on picking that up. Right, so guys, let's see if you need to screenshot it. I'm going to give you one more and then we're going to take a break. So here's question D. We've got 2, 4, 8, 16, 32. So again, think about what your pattern is. Think about what your next 3 terms would be. You can put your hand up, you can put it in the chat. Let's see what we think is going on here. Everyone is so on it instead of me. Even in the last class, I was making up like way too complicated things, and you guys are just on it tonight. Clearly, I haven't done number patterns in a while.
My people are understanding these things. Y'all are nailing it. Well done, my pips. Well done, my people. You're doing really good.
Okay, Valesa, tell me what's happening.
Ma'am, we are multiplying by 2.
Excellent. So guys, each time I multiply by 2, so 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. And so I keep going. Right. Emmanuel, do you have something different? Or do you want to give me the next 3?
Ma'am, I was gonna give you the next 3.
Okay, tell me.
Ma'am, so 32 times 2 is 64.
Good.
And 64 times 2 is 128.
Good.
And 128 times 2 is 256.
Excellent. Right, so guys, if we just keep timesing by 2, we're eventually going to get our next 3 terms. So that would be the 64, the 128, and the 256, as Emmanuel said. We see the pattern as timesing by 2. I just want to see something. Okay, so that is sort of what this pattern is. So again, different to the first 2 where we were adding the same thing each time, different to question C where we were, in that case, adding consecutive odd numbers. Here we're multiplying by the same thing each time. This is again a specific type of pattern that you'll deal with later on, but the important thing right now is to be able to see the patterns, to be able to see the multiplication by 2 or adding 4 each time or whatever the case is. Okay, well, Nati, do you have a question? Nope. Okay, so guys, if you need to, take your screenshots.
Time to shine. Take your screenshots. Y'all are doing really well, my pips. Well done, my people.
Right, just quickly again, because I've seen Muflago's question. For patterns, 4 patterns in a test where you have calculators, generally speaking, guys, you are always allowed a calculator. The only time you don't or can't use a calculator is if a question says you may not use a calculator. But honestly, from this point, calculator is your best friend. Use it. Even if it's just to double check 1 + 1, which I know sometimes we do. So use your calculators unless the question specifically says you may not. Okay. Righto. So here is our brain break for the day. And I really enjoy my joke today because I love a cow. So it's a goodie. I'm going to leave it with you and I'm going to just say, remember to think about when there's 2 ice creams or 2 cakes, what that means about the value. Tato, do you have a question?
Yes, ma'am. I wanted to say actually that in our tests at my school, they don't allow calculators.
Interesting. Okay. I mean, so some schools are different. I'll be honest, I'm very pro calculator. Just because eventually you're going to use it so often, you might as well start getting used to it. I know some schools, like you say, in grade 8, they're still quite strict about calculator use. Honestly, if that's the case, that's okay. You are just practicing your maths really well. From about grade 10, you'll probably start using them a lot more than what you do now.
Yes,
And also
ma'am.
just to add on that, Tato, it means that your school will never give you like big numbers to sort of calculate. So you have nothing to worry about. So they will give you like normally your square numbers, your cube numbers. As long as you know those, you should be able to do any calculation with your head. So it's normally like that. Okay.
Yes,
That's
ma'am.
it.
Thank you.
Okay. So I'm guessing all those hands, they are up for you guys to answer. So let's hear. Unati, do you have anything to say about the brain break? Anything that we should take note of?
Good evening.
Good evening.
The ice cream is 18 and one of them is 9.
Okay, so you said, I guess that's 18 plus 18 plus 18. Did it give you 54 when you put it on your calculator?
Yes.
Okay, perfect. Or anything else? So what about, oh yeah, you already mentioned that one coin then it will be 9, hey?
Yes.
Okay, do you know anything about the cake?
Not yet.
Okay, I'm gonna pass it to someone else. Thank you so much, Unatsi. Noku, I'm coming to you. Noku, on your side. Oh, Noki disappeared. Noku, did you disappear? Ayander, would you like to help us about the cakes or the ice cream? Well, the scope ice cream, not the other ice cream.
Yes,
Can you help,
ma'am.
Ayander? Yes?
Yes, ma'am. So ma'am, the cake, if I'm not mistaken, it will be 8.
Okay, so how did you get the cake? Would you like to explain to us why you think it's 8?
Ma'am, because I times 9 plus 9, which gave me 81, and then I subtracted 81 from 89.
Nice. That's some nice algebra calculations. Well done. So what about 2 cakes then? If 1 cake is 8, what about 2 cakes?
It will be 16.
Well done, girl. You nailed it. Do you want to finish it off? What is our scoop ice cream? What do they call these ice cream? The rainbow ice cream. Do you know what that would be?
Ma'am, I'm still calculating that.
No problem. On the chat, do you guys want to help Ayanda? Anyone? Okay, Emmanuel wants to help you, Ayanda, while you busy calculate. Emmanuel, we are all yours. What did you get for the rainbow ice cream?
Oh, ma'am, I got 8.
And how did you get 8?
So, ma'am, I said 16 times 16, which gave me 256. And then I said 264 minus 256 equals 8.
Yo, your algebra is mwah. Then what about one ice cream, a scope of ice cream?
4.
Well done. Would you like to give us their final answer? Like we should
Yes,
just
ma'am.
do the drums. What's the final answer?
18 times 16, which will give us 288, plus 4, which will give us 292, if I'm not
Well
mistaken.
done. We nailed it, my people. This was good teamwork. Well done to everyone who participated in this brain break. Hopefully your brain break is like now, fresh. And just to read the joke to you so you can appreciate it. How do you count cows? With a calculator. But it's so lame. Sorry. I needed to laugh it out. Guys, I found that really, really funny.
Letabo, you have made my day. That joke is
You need to get it. Look at the cow calculator.
guys.
It's there for you.
You have to know that I am like obsessed with cows. And so like a good cow joke is it's really just a lot for me. Oh, I had a whole bunch of cow jokes, but they're not math related. But I sort of still feel okay about it. Oh, what do you call a sleeping cow? A bulldozer. I'll laugh at it myself. Angeline's laughing with me. Thank you. Thank you.
You're finishing my voice over here. I'm trying to like keep it all in.
Oh, but there was another one. Oh. What do you call a cow with no feet? Lactose. Onati. A milkshake.
Hi, you guys.
Do you see I spent too
Give
much
me a
time?
good laugh this evening.
I spent too much time looking for cow jokes.
Oh my word.
So guys, if you ever want to make me laugh, cow joke. Doesn't even have to do with maths. You'll get a giggle. Alrighty. Let us continue on with our patterns. Okay, so we're going to chat eventually as we go along in this course about the fact that we can represent patterns and relationships with variables in a whole bunch of different ways. Now, this whole idea of drawing pictures to represent relationships is one that's very much based in patterns, but it is a good sort of starting point to understand that relationships between variables or relationships between values can be represented with a picture. And eventually the pictures we're going to draw are graphs. So it'll look a bit different, but the idea that we can use pictures to represent relationships is an important one. Okay, so if we have a look here at this image that I've given you, you've got 3 different images. So this would be image 1, image 2, image 3. And they are made up of blocks, right? So if we take a second, we count how many blocks we have, or we look at what is changing from one image to the next, I'm sort of going to ask 2 questions within this question. So the question A says how many blocks will be needed to make the 4th image. Then I'm going to add on to that and ask what would the 4th image look like. So I know that's a bit hard to potentially describe, but you can give it a go. Otherwise, you can obviously draw it for yourself. But it's a 2-part question. So how many blocks do we need for the 4th image? And then what would the 4th image look like? How would I draw it? Okay, so Ntabasing, do you have an answer for how many blocks? How many blocks?
Hello, ma'am.
Hi.
It's gonna be I think it's 13 or 14. Yeah,
14.
14.
Well
Yes.
done. Well done. Okay, so 14 blocks to make the 4th image. Excellent. Now, do you
Yes,
want to
ma'am.
explain to us how you figured that out? Hang on, I'll ask you to unmute. There we go.
So, ma'am, you're gonna add another 3 blocks.
Excellent. Well done. So guys, what we see, and this is why I also sort of put it out there, look at the picture. What we see is that from one image to the next, I add an extra row of 3 blocks. So in image 1, I've got 1 row of 3 blocks. In image 2, I've got 2 rows of 3 blocks. In image 3, I've got 3 rows of 3 blocks. So if I'm adding a row of 3 each time, what that means is that to go from one picture to the next, I'm adding 3 blocks as I go along. And so if I now want to get to image 4, I need to add another 3 blocks. Now, if I count how many blocks I have, I've got 5, then 8, then 11. And so if I add 3 to the 11, I get those 14 blocks. Now, this is also going to be helpful if we now want to figure out what image 4 will look like. So to Lilet, I hope I said that correctly. You can correct me if I didn't. What would image 4 look like?
Oh, ma'am, I don't really have an answer. I just want to ask a question.
Oh, okay, yeah, go for it.
Ma'am, what would happen if, say, they give us only 3, but they ask us for like the 6th term or the 6th image?
Okay, so that is a very good question. We are eventually going to lead up to it, but I suppose you've got 2 options. Option 1 is keep adding 3 until you get to the image you want. But that becomes a problem if I say to you like the 50th image. You don't want to add 3 50 times to get there. And so what we then need to do is find like a rule or find an equation that will allow me to figure out any value in my sequence. So if you want, we can have a go of trying to find a rule here. This will sort of take us back to number patterns and finding rules or general formulas for number patterns. But as long as you know what the pattern is, so here, as long as you know that you're adding 3 each time, you can actually find a rule. And what that then does is it allows you to do exactly what you said here. it allows us to go and figure out any image in my pattern or in my sequence.
All right, ma'am.
Does that answer your question?
Yes.
Okay. So
And I
what
do
we'll
think that, oh,
Yeah.
pardon me, ma'am.
No, you do think?
And I do think we should go through the patterns just one more time.
Okay. Alrighty. Okay, so guys, let's finish off the question that I'd sort of two-parted here. What would image 4 look like? So we've sort of established that we're adding a row of 3 each time. And so if we go to the 4th image, we should have 4 rows of 3. So I'm actually going to draw it here where I've got a bit of more space. So I would need to have 4 rows of 3. Now, obviously my drawing is beautiful. It didn't get any better. There are my 4 rows of 3 blocks, and then I've got the 2 on the end. Now, if I count how many blocks I have there, that is 14 blocks. All right. I'm going to pick on you mostly because you put it in the chat. But Betty, do you want to explain to us how you've gone and said my rule, as I was explaining to Tulile now, is x times 3 or 3x plus 2. You can raise your hand or you can type it in the chat. How did you get there? Because it's correct, but how? Or Theo, I see Theo actually had the same rule. So no, Naledi, not you. Sorry, Papedi. I hope I'm saying this right. I mean, Naledi, if you want to try, you're more than welcome to. Alrighty, guys. So like I was explaining now, we are eventually going to talk about finding rules and stuff like that. So it wasn't really my plan for today, but it's fine. The questions come up. Let's chat about it. We can try and find formulas or equations or rules that describe a pattern. Now, you guys would have learned number patterns in a bunch of different ways. Some of you might have learned the formula for number patterns of Tn is equal to A plus N minus 1D. Some of you might just do it intuitively. That's fine. Because we're not doing number patterns as our topic right now, I'm not going to use a formula. I'm just going to talk about this. So if I draw a very, very crude table here, and we talk about what image we're on. Ooh, please excuse the dogs barking in the background. And then the number of blocks that I have. So image 1 had 5 blocks. Image 2 had 8 blocks. Image 3 had 11 blocks. And image 4, we established had 14 blocks. Okay, it's a beautiful table. We can just pretend it's fine. Essentially, what we want to do is we want to find a rule that I can apply to each of these image numbers to get the value or the number of blocks. Now, this is what we call an input and output. Sometimes you can use X and Y. Really doesn't matter. So basically, I want to do the same thing to 1 as I will do to 2, as I will do to 3, as I will do to 4 in order to get the number of blocks that I have. Pelesa, do you want to ask a question or do you want to tell us what's happening?
Ma'am, I would like to give the rule.
Okay, cool.
So for the rule, I said the image number would be known as like X, and
okay.
So the rule would be 3x plus 2.
Okay, cool. So if we now relate this to variables, which we can, and this is eventually where we're going. So it's cool that we're using X's and Y's. This is what we call a general term or a general rule to describe this pattern. Now, if I go and apply this rule, remember Pelesa said X is the image. So if I substitute in 1 in place of X, I've got 3 times 1 plus 2. That gives me 5. That's correct. If I go and substitute in 2, 3 times 2 plus 2, that gives me 6 plus 2, which gives me 8. That is correct. If I keep going and substitute in 3, 3 times 3 is 9 plus 2 is 11. That's correct. And so what I've done is I found a general rule that will help me find any term. So back to Tulile's question, if I asked you for the 6th image or the 50th image or the 100th image, you could now go find it because you've got a rule. And this is one of the ways we represent relationships, through these rules. Okay, so we've gone off on a real tangent. That's fine. We're going to chat about this eventually. So now it's hopefully somewhere in your brains, but it's one of the ways we can represent relationships. And it's also going to eventually be one of the ways that we use to go and draw graphs. So Tulile, just because I can see your hand still up, do you still have a question, or does this sort of make a little bit more sense now in relation to what you asked?
No, ma'am, an old hand, sorry.
No problem.
But yes, it does answer my question.
Okay, good. We will do more of it, like I say, but hopefully, yeah, that helps a little bit. Spiwe, do you have a question?
Yes, ma'am. For a rule, I wanted to ask if I said x times 3 plus 2, would it be correct?
Absolutely fine.
Okay.
Absolutely. So generally, we always write the coefficient, then the variable, so the 3, then the x. But x times 3 is absolutely fine as well. You'll see it'll always be presented to you as a number, then x. So you'll sort of get into the hang of it, but it is the same thing. So no problems there at all.
My learners are beyond. Oh,
I know.
guys, I'm so proud of you.
This is
Y'all
a really
are
cool
doing
lesson,
the
though,
most.
'cause lovely tangent. Okay, so because we've gone on this whole fun, like, little journey here, I'm gonna make that a tad smaller, and let's see if we can answer this question C. How many blocks will be in the 23rd image? You can put a hand up, you can put it in the chat. We've spoken about a rule. We've spoken about how we get from one image to the next. So let's see if anyone can give me an answer of how many blocks will I need to make the 23rd image. Okay, I saw a few questions in the chat. So Watermelon, I'm not 100% sure if I'm understanding your correction, but input and output numbers are very similar to X and Y. So your input is X and your output is Y. Sometimes I can give you an output and expect you to find the input, but I would have to then tell you what like the formula is. So this Y equals 3x plus 2 or something like that. We are going to speak more in our next lesson about input and output values. So hopefully it will make a bit more sense. Guys, graphs will be in your exams at the end of the year because it is a grade 8 sort of topic, unless of course in your school you haven't covered graphs. You will obviously cover what your school tells you to cover. This is part of the grade 8 syllabus, but obviously if your school doesn't do it, they might be leaving it for grade 9 and then it won't be in your exams. But just ask your teachers what will be in your exam and you can double check that. Okay, Kwakutle, can you explain to us how you get your answer and tell me what your answer is?
Sorry, nerves. So I substituted the x with 23.
Good.
And did 3 times 23.
Good.
It was 69, and I added 2, which was 71.
Excellent. So guys, in this case, because we knew what the rule was, we could go and just, exactly as Kokukle said, substitute, right? Through substitution, I get that if I drew this pattern out to the 23rd image, I would get 23 blocks. Now, obviously, this rule makes life so much easier because imagine we didn't have this rule. Without this rule, I would literally have to add 3 all the way up to the 23rd image. So like another 20 times to get my answer. That's a mission. And this is why we have ways to find a rule or to find an equation to help us bypass all of that nonsense. And so exactly our answer here is 71 blocks. Awesome. Well done, guys. You are on it tonight. And we've had some cool conversations, which is always fun. Okay, Tato and Rubetswe, I do still see your hand. So if you've got questions, you can leave it up. If you don't, you can lower them down. Okay. Mhlago, let me just read your question. Would you answer C like how you answer? So for Mhlago's question, they're asking, would you answer C the way sort of we've done it, the way you would do it in number patterns? B, what pattern do you notice? The pattern that you notice, I suppose, here is that you're adding 3 blocks each time. So it's more like a description of what you see, no stress. So you would just describe what you're seeing. Okay, now lady, there is a poll.